Hey guys, welcome to this new movie of Chapter 3, a first movie as well. The chapter is called Water, and water is pretty special. It is so special that our world will be totally different without water, or if water would have different properties. Um, it keeps our keeps our planet roughly the same temperature all the time. Your body consists of lots and lots of water, and water is one of the few things, or the only thing, we can actually see in three phases, as states of matter. And well, these states of matter, scientists call them solid, liquid, and gas. And what is the difference and what is an example? First of all, of course, solid. An example is a table or a pen. And liquid, an example is the water you drink. So drink something, and a gas is, for instance, the air we live in. And how can we distinguish between what is so special about a solid, what is so special about a liquid, and so on? A solid has a fixed shape. Shape does not change. Um, my mark does not change shape. But the liquid, if I pour some coffee in it, then the shape of the coffee in the coffee can will change into the shape of my coffee mug and I drink it. And then it's changing shape as well. So with a liquid, shape can change. But you cannot compress it. If you have a balloon and you fill it with water, you get a water balloon. And if you try to compress it, it's not possible. Okay, and what about a gas? Well, I can move through gas so the shape can change. And if you put it into a balloon, then you can put more and more and more air into the balloon, and at the end, the balloon will barely expand, but you can still get more and more air out of it. Or a better example, for instance, if you pump your tire. You pump more and more and more and more air in it, but the your tire will not increase the volume, so you can compress it. So a gas is shape, oh, and volume can change. So you can compress it, you can change its shape. Hey, we're going to, this is basically what is in one of the few questions about what is what. What is a solid, what is a liquid, what is a gas? So you basically need to ask yourself, can I change the shape? Can I change the volume? Yes or no? And when we take a look at this cattle, one of the most striking things or strange things most people have is that you cannot see water vapor. You cannot see water if it's a gas. And I'm going to show you. Just take a look at this kettle. It is steaming hot. And you can see that because there's some misty thing on top of it. But if you look close, very close, over here, you can see that there is no mist over here. You cannot see anything over here. There, where it is very, very hot, it just came out of a steaming hot kettle, you cannot see it. And only later on, when it's cooled down a bit, when it has been condensated, then you can see it. It's the same if it's cold and it just rains, then you feel it's chilly, it's cold, it's wet in the air. There's wetness in the air, but you can still see through it. So apparently there is water vapor in the air, but you cannot see it. Water vapor is not visible. It is not really, honestly. Okay, enough about this. One of the things we've started with last chapter and we're going to expand is how to uh, explain things with the particle model. And the particle model is, I think, best understood if you play with it. So I basically want you to go to this website. If you Google PET, P-E-H-T, then you get this website. And then you can, for instance, Google over, search over there, state of matter, and then we go to basics simulation. And then we press the play button. It's HTML5, so each device should be able to do this. States. And over here you can see the temperature in Kelvin or change it in Celsius. I don't care. We can change the atoms and molecules. Well, over here we can see water, and you can see that it looks a bit different than, for instance, oxygen or argon or neon. That's because they are different. Neon and argon, they're only one molecule. Oxygen or O2 consists of two oxygen atoms, and water consists of its H2O on two hydrogen molecules and one oxygen molecule. But for the particle model, it does not really matter, because the particle model thinks every molecule is a sphere and it acts like a sphere. So we're going to get rid of that water, that deeper detail of water, because we're going to look at a model, and the model of this is good enough. So that's always the case with a model. It's a simplification of reality that is good enough so you can actually explain things. Okay, here we see a solid, a liquid, and a gas. What can you see with a liquid? You can see that they are basically molecules on a fixed place that are jumping around a bit on the same place. They are not moving around, just simply vibrating on the same place. How is it with the liquids? Try to follow one molecule somewhere in the middle, and you can see that it moves around a bit. The molecules stay down, but they move around a bit. They're not attached to each close, not really strongly attached, but they just keep next to each other. And then with the gas, they're moving around. They're everywhere. Okay, how do we write it down? As a solid, we have molecule vibrating at a fixed place. With the liquids, we have molecules moving through each other, next close to. And then last but not least, the gas. We have molecules moving all over the place. Okay, what I would like you to do, first of all, this is a note that you basically need to learn, so please copy it. And then I want you to think about how to explain how the particle model works. And for that, I do encourage you to take a look over here and take a look, what does the heat do? What does it do if the heat goes up, it cools down, and so on and so on. Just play around with it so you get a feel for the particle model. Hey, play around with the game for science. Okay, and yeah, do try to explain why a solid does not change shape, a liquid can change shape, but you cannot compress it, and a gas you can compress it and change the shape. Okay, hey, bye, see you Monday.